Good afternoon, ladies and gentlemen. My name is Wolfgang Emmerich. I'm the CEO of Zühlke UK, and I would very warmly like to welcome you to this afternoon's webinar. We want to share with you some insights that we gained when we built the NHS COVID-19 app earlier this year. And I'll be joined this afternoon by my colleagues, Neil Moorcroft, Stefan Jenisch, Shamil, and Christian Janet. I'd like to ask everybody if they have questions to enter these questions into the webinar questions box, and we will then collect them and address them at the end of the webinar. So we are going to talk about how we built the NHS COVID-19 app. And that was quite an interesting project for us. It was quite a large project for us, and it's quite a critical project for the country. It's not a project that Zühlke was only responsible for, but it's rather a concerted effort by quite a few organizations, including the Department of Health and Social Care, our main client, the NHS Test and Trace program, and a number of other companies, Rush, who built the QR code, Accenture, who ran the program office, AWS will provide the hosting infrastructure. We worked with Apple and Google using the exposure notification API, the Alan Turing Institute as scientific advisors, and the National Cybersecurity Center, who provided the security advice and did the penetration testing. The project has built what I would argue is the world's best contact tracing app. You all know what the app does. It traces contacts of people who have tested positive and alerts them. But it has also a number of other features that make it the feature richest app in the world. So when we built the app, we compared what other countries had done, and we made sure that the UK app had the richest feature set. But the app also has a number of non-functional characteristics that make it world leading. It has been built in record time. We launched on the Isle of Wight after 6 weeks of development. It is very highly used. We've reached more than 20 million downloads a few weeks ago. And we would argue that it's also the most precise app in terms of contact tracing algorithms. And if we have time, we can talk about that later. We've built the app using privacy by design. We have worked very closely with the Information Commissioner's Office on making sure that all the contact tracing details are kept private on people's phones. It is a Class 1 medical device, so we have been awarded the CE mark by the MHRA. And normally, building a medical device takes years, and we only had weeks to build this. The app is AA compliant, which is a very high accessibility standard, which means that people who have visual impairment can use the app, and the app will talk to them and listen to them. It supports a large number of different languages that are commonly spoken in England and Wales, and the app is actually continuously improved as the situation requires in the response of the government to the pandemic. So the app uses the Google Apple exposure notification API, and we were probably the first app in the world to use the V2, the second version, and as a result, we have been able to very considerably improve the precision. Now, the development of the app is also remarkable because of the speed with which it had to be done. A decision was made in mid-May to actually and in early June to pivot to use the Google Apple API to adopt a very decentralized design and incorporate privacy by design. We then had effectively 6 weeks to launch a pilot on the Isle of Wight and the borough of Newham, and then another 6 weeks to the national launch that happened on the 24th of September, and then another 4 weeks to prove that the app would work at scale. So the launch date was critical. The national launch date was critical because it was rightly predicted that there would be a second spike in infections, and that the app was seen as a key weapon in the arsenal to beat that spike. And since we have launched, we have made a number of improvements to the app, and we will continue to improve the app continuously. So now sit back and relax while my colleagues talk you through what has been a remarkable journey and how they will focus on how we've achieved the building of this app on a very tight schedule to national launch. So Neil.
Thank you, Wolfgang. So as Wolfgang said, we didn't do this on our own. We were the technical delivery function of a larger COVID app team. It included, as you would expect, product ownership, assurance, compliance, marketing, comms, etc., and so on. But what I think is quite unique and vital for the speed of development here is to build a highly cohesive startup organization within a larger government department. Having that startup mentality meant that we had the authority to make decisions very quickly. You know, our executive management team were empowered to make calls rapidly and allow us to solve problems and move on. Also, having policy embedded deeply within the agile development process is absolutely vital. There's no throwing it over the wall from policy to an engineering team to deliver. So building that startup mentality, I think, was vital. So can we skip on to the next slide? I don't have control. Okay. Sorry about that. Yeah, so within that technical delivery organization, Zulka brought in an end-to-end delivery team, an end-to-end delivery organization. Absolutely vital for speed here, bringing in one large team with one culture, able to hit the ground and immediately start delivering value, you know, day one. There's no time to norm and form as you might in a larger project. We set ourselves up into three main pillars: a design pillar where we looked at we had squads focused on service design, architecture, domain analysis, the UI UX work. A delivery pillar, we had squads focused on the mobile app, the API services, and some of the other larger features of the system, and then an operation pillar, and doing the release management, the incident management. But key to that is building a secure underlying platform on which the other teams could deliver. Key to this was building a continuous flow of features through this model. You know, the features went through design, delivery, and operation in a continuous flow, so that we were able to we weren't blocked by by waiting for earlier teams to finish. So very fast-moving situation. You know, the situation on the ground changed daily. It was often joked that we found out what we were doing each day by watching the news in the morning. So had to be able to respond incredibly fast to changing changing environment. So key was to put together a very short lead time, be able to, you know, to take a story from the roadmap, take an epic from the roadmap, refine it fast, build and test, push it through assurance, and get it out the door. And so we built an overlapping model that you see here, an overlapping continuous delivery model with the ability to potentially release weekly. In fact, we often did. I mean, the mobile app may not have gone out weekly, but back-end services and so on often did. The key to making that work, though, is to also, you know, we're in a controlled environment. So, and we'll see in a minute, you know, this is a Class 1 medical device. So we also need to make sure that we have the necessary governance work in place. We also do the required design and architecture work. So, you know, following the GDS model, we needed to do discovery on features, but we needed to do it fast. So put together a very short, often just 3 days or up to 5 days of discovery work per feature. So feature requests come in, we need a change board so that we can have approval, and, you know, policy gets to you know, sign off what we're doing. That fell down into a set of approved requirements that we could then do very quick iterative design and architecture work, being fed by you know, policy, by medical, by accessibility consulting. We had a lot of accessibility by design at this stage. You know, we had focus groups of disabled users actually working on the prototypes to make sure that they were fit for purpose, as well as more wider user research groups. Key to this is to generate a roadmap, a continuous flow of sized epics that could just be picked up immediately and taken into that rapid continuous delivery cycle. So yeah, I mentioned medical compliance there. You know, this is a Class 1 medical device. We needed to get our CE mark. It was really important. This obviously, you know, I'm sure many of you know, has a substantial overhead on the development process. Biggest impact to engineering is the document control and the release management practices that needed to be put in place, as well as the rigorous testing we needed. You know, very high unit test coverage, very high automation test coverage, as well as a manual assurance process and so on. But actually, the key here is to bake these into the development cycle, make sure that you know, we embrace them. And in fact, many of the practices that you know, that these compliance standards are driving actually speed you up in the long term. You know, and make sure that we you know, we deliver quality software continuously rather than having to go back and fix later. Many other governance and compliance standards we needed to meet, and again, we baked these into the process. But some of the key things there, we obviously were overseen by the government digital services, GDS compliance. So huge amount of effort goes into usability testing and user needs research up front. Still trying to do that, you know, even though we have to go fast, we still, every feature was tested, every feature went through user research. Fully open sourced, again, key to make sure that this is trusted by the public, and making sure that the code we write is out there and available for people to investigate it was key. So we went through that process. The Information Commissioner's Office, as Wolfgang said, needed to be private. Private by design, needed to be anonymous. We needed the trust of the public to get the adoption we needed to make this actually work. So making sure that the public understood that it was private, understood that the government were not tracking them, it was key. So working closely with the ICO, publishing our DPIA continually, keeping it up to date was key. We had NCSC, part of GCHQ, embedded within our team. Really rigorous. These guys absolutely know what they're doing, and they're checking every aspect of work. And again, getting those security concerns and those privacy concerns baked into the project as we go was key. And again, as I mentioned, and Wolfgang mentioned, the WCAG AA compliance. Really hard to hit this, especially in a mobile app. So making sure we had disability user research baked into the process, we're checking it continuously, was absolutely key to making sure we hit that target. Okay, so just onto the architecture a little bit. I've got some of our engineers on who'll go into much more depth than I can on this, but just some of the high-level principles on the architecture. We use cloud, native cloud services wherever possible. And in fact, that was a real core principle of ours. We want to be able to scale. We want to be able to take advantage of that AWS infrastructure to support, these millions of users we need. So always going for that native technology where possible, never writing anything ourselves when there's something there available. And of course, that allows us to keep the architecture as simple as possible. We always went for simplicity where we could, but also whenever we establish a pattern, and you can see some of our sort of high-level patterns here. Whenever we established a pattern, we made sure we stuck with it. We didn't allow teams to drift off and do their own thing. We had a limited number of technologies and a limited number of patterns that we knew well, we understood. And we understood their performance characteristics and their cost characteristics very well, so we weren't surprised later on. And of course, that use of AWS and native architectures, it did us proud. We were able to scale to millions of users and still keep the cost relatively low. So yeah, currently round about the 20 million install users using the app install base. 700 million user requests per day. We're serving up around 12 terabytes of data each day. And we make use of the automatic scaling of the infrastructure to be able to handle those peaks and troughs seamlessly. Huge amount of S3 use and CloudFront to distribute the keys at scale, make sure they get out there quickly. Probably the highest load is the analytics. Nearly everything else we can use CDNs and the like to spread the load, but we do need to know whether this is actually whether this is actually working, whether it's actually affecting the course of the virus. So we bring in anonymous analytics. That service is a steady state of between 20 and 40 requests per minute, and often hits a peak of 300,000 requests per minute, which is quite a serious high load. So I'll now hand over to my technical guy, Stefan here, who can, for those of you who are technically minded, can dig in a little bit more to our architecture.
Yeah, thank you, Neil. I mean, Neil promised some details, and here we are. So this is a diagram full of details, maybe too much to see everything on that screen, but it's a diagram you also find in the public, in the open source repository. And what we now do is just to give you a little bit of an overview so that we can have a Q&A afterwards, and also you are then able to navigate these kind of diagrams in the open source repo as well. So what you see here right now is the port-based view on the system architecture for the app system. And with this, you have on the left-hand side, you have the key user interactions with the mobile implemented on iOS and on Android. The mobile itself, the app, has several backend ports integrating with the cloud services we've implemented in the middle part of that diagram. So the cloud services on the one hand provide all the APIs for the mobile side, but on the other hand also APIs for the external systems and data sources we needed to integrate for the full flows. data flows needed to implement that that app you saw before on that informal high-level views. And finally, on the bottom left, you see our integrations with operations. So for monitoring and alerting our systems and infrastructure. All right, and then you remember the timeline view some slides ago, and we were asked when we did the tech spike to have a look at the Google Apple exposure notification API. In particular, we needed to look at the possibilities to implement based on that API encounter detection and exposure notification. And this is exactly what you can see in that diagram as well. So in the left, on the left-hand side at the top, there is a interaction BLE encounter detection. And this is exactly this interaction provided by and implemented by the Google Apple framework and API is encounter detection between different apps, between different devices using Bluetooth. And the exchange is via temporary exposure keys. And what we did was we implemented that part. And then additionally, we needed to implement for the tech spike a cloud service, which allows to, on the one hand, allows the user to upload his temporary exposure keys, and on the other hand, to allow other users to download these keys. And since it was a strict requirement to enable this exchange of temporary exposure keys only for those users who've been tested positive, we also needed to implement for that very first tech spike a virology testing integration so that we can make sure that with the exchange of test results and a positive test result, the whole flow, uploading and distributing the keys works, and then the user get exposure notifications on their mobile if they've been in contact with someone who tested positive. So, and since that tech spike, we then moved on and implemented first the MVP, which included a number of additional APIs and services needed as part of the cloud services, as well as a part of the backend ports on mobile side. And we continued with that MVP hardening and making it really production ready until mid of September, and then we did the national launch with a architecture which really grew through that time from that very 1 or 2 ports to the whole architecture you can see here on that view. And from the very beginning, we decided, as Neil already showed, to implement a truly cloud native architecture, because this was the only way how to implement it in such a fast way and also in such a scalable way. And this implementation, these decisions, architecture and technical decisions on cloud native things, this is something which now will Chris and Jamil will explain in a little bit more detail than I did so far. So Chris, it's your turn.
Thanks, Stefan. Can we quickly jump to the next slide, please? All right, so now we're zooming into the backend, to our cloud native infrastructure. What we basically see here is, so we have a headless backend. So we only provide APIs to our mobile applications and to external systems. So we only have front ends on the mobile, native iOS and Android applications. And as mentioned before, we decided to go full in with a serverless architecture. It's as simple as we don't have the time to spend energy and mental capacity on spinning up VMs, setting up databases, provisioning hardware security modules, and so on and so forth. We wanted to focus on bring the backend to life, bring the APIs to life as fast as possible, and also count on a really reliable, scalable platform that ensures that we can handle 20 million devices. So what does that mean exactly? So we identified different patterns, as already mentioned before. So one of the most important patterns are our distribute APIs. So I think the main goal of our backend is to provide data to the mobile phones. Is it risk level data, risky venue data, configurations that needed to be updated from time to time, and amongst others also diagnosis keys we want to share within the mobile applications. And these distribute patterns are implemented with a simple S3 bucket that stores the information combined with the CloudFront distributions. So our mobiles directly download data from S3 via CloudFront via HTTPS. And therefore, all the scaling is basically a managed effort of the AWS platform. It just does scale, and yeah, well, we can focus on other things. So another important pattern are our submission APIs. So we also need data from the mobiles. So if a user decides to share the diagnosis keys, they need to be uploaded. Need to integrate the test labs and to provide a test result uniquely for the owner of the test token. So for these APIs, we did come up with a very simple pattern, which is API gateway in front of lambdas. We did Java-based lambdas for various reasons. And Lambda, we were able to quickly spin up highly scalable APIs to accept data from the mobile phones, but also from our external systems. And with S3 and CloudFront, we were able to distribute data at scale. Furthermore, we also have time-triggered functionality to aggregate data and recalculate data, and we use event bridge schedule rules to trigger lambdas for that. When it comes to security, well, we also rely on managed services. We use Amazon Certificate Manager to get a managed TLS cert basically for free. We use KMS for responsible designing. So in addition to HTTPS, our friends from NCSC basically recommended that we also do sign our data, our dynamic data, our static data, to have an additional layer of proof the data is coming from the right source. So we use K management services to sign the data. We use internally secrets manager and KMS to store secrets, and our configuration parameters. When it comes to DNS, we use a managed DNS offering from AWS Route 53, and the list continues and continues. You see various services mentioned on that diagram. We decided when it comes to state, we also go serverless. So we heavily use S3 to just store JSON or CSV or Parquet files in S3. If the access patterns requires a bit more flexibility, we choose DynamoDB. But as I mentioned before, it's all serverless. So these databases just scale and can handle traffic coming from 20 million devices without us need to really bother about it. So in practice, we actually did tweak the system a bit. So obviously the default quotas that come with the fresh AWS account are not sufficient for our workload. So we increased several quotas, and we're in close contact with our friends from AWS, which also did have quite some good recommendations how, amongst others, to save costs and may come up with a system that is as reliable as possible, but also as cost effective as possible. I think, let me quickly reiterate if I did forget something. I think that's basically it. So it is actually quite simple, and that's by purpose. We decided to not, come up with the simplest possible way to make that system happen. And one detail I could probably mention is notifications. So in our case, a notification is actually a mobile phone polling whenever the mobile phone gets background processing time and trying to download information from S3 via CloudFront. So we don't use APNS or Firebase. We decided to come up with a very simple pattern that is very resilient when download is not possible due to network outages or whatever reason. The mobile tries again later, and that's also the case for our external facing APIs. So by designing a system end-to-end that relies on simple read-write logics, exponential backups, read-write later, we can come up with a system that is end-to-end available all the time, and it allows us to deploy whenever we want without negotiating with external partners when actually to deploy stuff. So we also do not need blue-green deployments. We just deploy whenever we want, and the system end-to-end just works fine. One last comment to a very interesting thing that is how we actually manage all this infrastructure. You can see all these boxes are AWS services that need to be provisioned. So we decided to use HashiCorp Terraform to automate all the infrastructure. So all you see on that picture, yeah, more or less, can be automatically provisioned within around 15 to 20 minutes. So from zero to production in a prepared account that has all the security properties in place is a matter of minutes, and incremental deployments are even faster. So in reality, yeah, in a week, we basically create several new environments to work on new features. So isolated prod-like environments where we can try out new features. Once we are happy with it, we merge code to master and roll out it to prod. And for CI/CD, we did use GitHub Actions, and we are in the process to moving CI to code build to be a bit closer with our infrastructure as code to AWS to even spinning up new environments. I think that's basically it from an app point of view. And now I think Jamil can join the conversation and talk a bit more about infrastructure and security.
Hi. So I'd like to sort of quickly run through the operations side of things and the security side of things. So I'd like to sort of re-emphasize again the fact that we decide to go like fully cloud native and use AWS built applications rather than trying to bring in other applications into the ecosystem, which helped us to get up and running very fast. And then it also helped us to get a full end-to-end integration into our system in terms of logging, monitoring, and alerting and security. So our team worked very closely with the NCSC and the Cyber Defense Operations Center set up by the Department of Health and Social Care. So we had these two parties who were advising us around how certain things need to be configured to set the monitoring in place properly, and auditing the work that we did, and also various chats with our colleagues at AWS who helped us with making sure that the architecture and the system that we designed does the work in the way that AWS best practices would recommend. I'd like to sort of highlight a few small things in architecture. So as Christian said, we distribute a lot of the stuff, and a lot of our interactions happen through CloudFront, and we use AWS WAF and Shield Advanced in these areas to make sure that we are protected against any kind of distributed attacks. And also we have restrictions on IPs, on protected APIs, so that we keep things closed. And parts of our infrastructure has connectivity into the Cyber Defense Operations Center, which send logs that we find suspicious. So let's say an attack comes into our WAF, and the WAF decides to block it because it looks suspicious, and we sort of tunnel that information to CDOC, and some of our CloudTrail events. And also we use services like AWS Config, AWS CloudWatch, AWS GuardDuty, which periodically run audits of our infrastructure to make sure that everything is in place, all the security protocols are observed. And another part of the work that we do is we do secure key exchanges with external third parties. So we do a very secure transmission of that and set that up inside the system where we have connectivity into third parties. I think that's sort of all the time I have. If you have any questions about anything specific, just ask away. In general, our focus was trying to use a lot of cloud native technologies that are very tightly coupled, that gives us the best security possible. And one thing I kind of missed was our alerting process, which we have any kind of events that these monitoring applications trigger, they are propagated to our Jira service desk, which would then generate an alert on Opsgenie. And also we have more alerts going into our Slack with our Slack integrations. And if you have any specific questions around that, I can go into that. I will hand it back to Neil. Thank you.
Yeah, thanks, Shamil. As the guy said, yeah, any technical questions, please put them in the chat and we can answer them. Okay, so I think Wolfgang was going to wrap up. Thanks.
Yeah, so really what we tried to convey in this last half hour is that it's possible to build a highly scalable, highly secure, and highly feature-rich app in a relatively short period of time. But in order for that to work, that you have to meet a few key prerequisites. The first of which is that actually, if you only have 6 weeks to build the first release, you don't have any day to waste on team alignment and storming and forming in the team. And we were able to avoid that by basically having a one team culture where the whole development effort and the development processes are aligned from just one vendor. Also critical for this is to actually be pretty ruthless about establishing a startup mentality in order to get the speed that is required, and that required a few changes as we've seen, and that ultimately enabled us to go really fast. We have adopted agile processes slightly to be able to deliver a weekly release schedule. So Neil talked about how we staggered the discovery work and the build and test work and the assurance work. We also had parts of the team in our Asian offices and parts of the team in Europe, so that we actually have a 16-hour development window every day. That necessitated a couple of handovers. So we were able to do a really nice agile delivery to create weekly releases. We had to embed governance mechanisms to do both speed and compliance at the same time. If we had taken the view that we worry about security afterwards, or we worry about AA accessibility as an afterthought, or we try to first build the thing and then compile the file for the MHRA submission, we would have failed. So it was crucial to actually align the governance activities with the development activities. And finally, this whole thing would have not been possible without AWS and the adoption of AWS services, the native serverless architecture that enabled us to entirely delegate the heavy lifting to the AWS infrastructure. So that said, I'd now like to open the floor for any questions that you might have.
Okay, I'm Bruce DeBarclay. I'm just looking at some of the questions in the chat, which are there, and maybe we'll get the first one, which says, "Do you use push notifications, or would that be too privacy intrusive?" Who would like to answer that question?
That sounds like one for Stefan.
Yeah, I can pick that up, or Stefan.
It's simple.
I mean,
yeah, you go, Neil, you go.
Yeah, you can dig into the technology. I mean, we push notifications do require basically a database of all of the phones that are currently registered to receive those push notifications, and so we felt, along with with our discussions with the ICO, that would make users feel that they are being tracked in some way. We would know, we would have a list of all of the users that are currently registered and listening. So we decided against that technology and went for this pull approach that Christian mentioned, where each device wakes up periodically and request from the server the current state and whether it should show any notifications, and that was deemed to be more private. Do you want to add to that, Stefan?
Yeah, it's all said. I mean, it's really the privacy is exactly the one of the most important reasons, and a technical reason which comes along the keep it simple would be reduce the number of systems needed to be integrated. So even if we would be allowed to use push notifications, we probably wouldn't, because it had introduced another part of the system and make integration more difficult. And so in that sense, we work fine and well with the exposure notifications as provided by the API of Google Apple.
Okay, thank you. There's another question here. It's interested to understand how the testing results were integrated into the API services. Are the test results received through a CSV or similar endpoint and then processed? Is this something you can answer?
Chris, do you like to go into APIs? Still muted.
Can't hear you.
Yeah, sorry, can you ask the question again? I tried to find the
Yes,
question.
it says, interested to understand how the testing results were integrated into the API services. Are test results received through a CSV or similar endpoint and then processed?
Yeah, let's quickly jump into that, because that's also really interesting how to do it privacy preserving. So basically we have a mechanism that we have, one of the journeys is to book a test through our app. So what we do, we generate what we call a token, so a unique identifier only the user knows, and basically a second identifier that basically is the MFA variant of the token. And then we start the journey handing over the test book into another website. Eventually that token will flow to the testing labs, and then the testing labs will send us back the result, and only the result and the date, and no other information like name, birthday, whatever, to our backend. So basically the interface between the test labs and our backend is a simple HTTP API, a JSON upload. We basically just two kinds of information: a correlation identifier that only the app stores of the user that has ordered the test, and then we make that information available, and only the owner of the result can request the result via our APIs. So with that mechanism, we ensured that it is privacy preserving. We don't know what test belongs to what person, because we don't store identities. And the only thing we have is a token stored on a mobile phone that is able to receive the result. And yeah, hopefully that did explain it a bit.
Okay, thank you very much. The startup mentality in government, what lessons has Zolka learned, and can this be applied elsewhere in the government? Wolfgang, maybe you want to take this?
Maybe Neil should take this. He's been closer to the core.
I think it can be applied elsewhere. I mean, it's a particularly unique set of circumstances here, so you know, it was well suited to it. But we built, or the organisation that was set up built a full organisation. You know, we had an executive team. There was a managing director. There was you know, a delivery lead. There was a technical lead. We implemented all of the functions that you see on the diagram. You know, comms, policy, and everything. And we worked as one team. We had morning stand-ups where everyone got together and dealt with the challenges of the day. We had an evening stand-up where we again addressed all the challenges of the day as a leadership team. And we were empowered by the wider program to make all the necessary decisions that we would need to make to be able to deliver quickly. I mean, obviously we are within government, so we, you know, there are certain decisions that need to go up to you know, more senior bodies, Secretary of State and whatnot, but the vast majority of management decisions could be made within that team, mainly because we had policy embedded within it. You know, the policy were always there, always available to answer questions, and always able to make calls. So I think yes, to answer your question, I think it can be reproduced elsewhere, but it takes a lot of effort. You know, these things can't be side of desk, and you can't. You know, you need to dedicate the full team to all the personnel to the project at hand, and often that isn't possible. But certainly for something like this, where there is a, you know, a single goal, we can build a management structure and a delivery structure around it.
Okay, thank you. A slightly more technical question. Does the application need to have a component that exists on N3 in order to interact with systems like NPEx? Who would like to take that question? Does it make sense?
So maybe we need to ask back. So I'm not familiar with N3. So NPEx is one of the systems that deliver us test results. I asked my colleagues if they're aware what N3 is.
We might be getting a little bit into the technical detail here. I wouldn't like to expose too much. I mean, maybe could you give the question more context, maybe? Yeah.
Unfortunately, if the person could put more context into the question, into the question line, that would be great. How does the English app, there's another question coming through, how does the English app, or English and Welsh app probably, compare to the Scottish one? What can be said about that?
We haven't been involved in the development of the Scottish app, so I couldn't comment on specific features. We have worked closely with them on interoperability, so you know, in terms of key exchange and making sure that the contacts in England are shared with the Scots and vice versa. Then we have worked closely with them. Yeah, I mean, I can't go. I won't go into detail about the differences, other than we have some extra features that were requested, like QR code and so on, which I don't believe they have yet.
Okay. Another question. It says, on the startup culture applied in the one team approach, would you see benefits in simplifying or changing the development process for future projects? Would you see really the essence of the question?
Sorry, you broke up there, Brewster.
Sorry, it says I'll say it again. On startup culture applied in the one team approach, due to time limitations, but would you see the benefits in simplifying / changing the development process for future projects? Would you change? I think the essence of it, would you change something from what you've learned here?
I mean, yeah, I mean, in effect, we're already doing that. So as we move to business as usual, the very strong, close leadership that the app has has sort of moved more into the test and trace program as a whole, and that's been beneficial because we can now work on features and deliveries that span across test and trace and be more aligned with the wider program. So in some ways, that startup culture, that very focused, close-knit team was fantastic at getting the app out in time. But of course, it creates a silo. So what's now happened is we have a more broad management structure and a more traditional setup, and we're moving towards that. And we can now share capabilities, assurances shared across multiple programs within the wider test and trace team. So, go on.
In general, it's a question about trade-offs and what actually matters. So in this particular instance, time was basically of the essence, because the later we could get the app out, and the later we would get important features out even after the national launch, the bigger the impact would be that we would miss. And we had to make certain adjustments. So this staggered release pipeline that Neil talked about is not without its disadvantages. It's got disadvantages, and if you were able to do this sequentially, if you had the time to do this sequentially, you could probably get the work done in a slightly more efficient way. But the trade-off was made here to actually compress the lead time and probably pay a slight penalty in terms of inefficiencies to get the work out as quickly as possible. So depending on what the circumstances are of any other projects, we would make different trade-off decisions, I think.
Okay. Another question. How do you feel the ongoing maintenance is going and being managed, especially in response to public feedback and scrutiny?
We have a very strong service management team that operate a hypercare approach to defects and feedback. They pick up issues raised by the public through various channels, website, and so on. We also, I think, as Christian and Stefan mentioned, we have a huge amount of automation and monitoring of, so we apply SRE type practices to monitor errors and the like within the APIs and services, and respond to issues and defects particularly fast. I think at the moment, I think there are certain things which were difficult to fix. I think there was a very challenging blue screen issue which made the news for a period that actually was caused by some very challenging issues within the operating system that we needed to work with Apple on for a period. Some of them take time, and comms need to manage the press that builds up around that. But the vast majority of issues that are raised by users, we've resolved particularly quickly and are rarely noticed by the majority of people. So I think it's been particularly stable, and we're very pleased with it.
Okay, thank you. This is a clarification of the N3 question. It says N3 being the NHS network. now renamed to HSCN, NPEX exists generally on N3 to send results. These systems are public. Then he says, what I wanted to know was, did you have to set up a connection into the existing NHS network, or were you able to operate fully separately without a network connection into the rest of the NHS network? Is that easier to answer?
So maybe I can start and Jamil can also contribute. So basically we integrate over the internet. We ensure with measures like Jamil mentioned, web application and basically IP whitelisting, that only the sources can integrate with us that are allowed to do so. We have bearer tokens and security to ensure that only authenticated systems can talk with us. But basically we use the public internet to integrate with most of the systems. For some systems that are also on AWS, we do the shortcuts. Most of them is over the public internet via secure channels.
Okay, thank you. I don't know if this information is public government information, but it just says, how much does the infrastructure at this scale cost per month, roughly? I don't know if the government has allowed this information. Not sure.
We do not have those details, I'm afraid.
Okay, didn't think about that. Let me just see if there anything else. Does anybody else have any more questions which they would like to send through? On that, I think that's pretty much come down to all of the questions, unless somebody else has something else. Do you have anybody, Wolfgang, any final thoughts on this before we finish?
No, I'd just like to thank the audience. It's nice to think that we had about 100 people over lunchtime interested in the topic. And if you have any more questions, just drop us a line and we can pick up the phone if need be. Thanks very much.
Thank you very much, everybody.
Bye.
Thanks a lot. Bye-bye.